Hi, welcome. This is my final project. It is from the scraped data that I got from the Baseball Almanac, and um, there's a few different graphs and some interactive uh, components of the dashboard. So the first graph was actually to show how efficient the team's payroll was to their wins. So there's a lot of information on this graph, but basically I have the minimum cost per win for the league. And then I also have the average cost, which is the black dotted line. And then I also have the average wins, which is about 81, which is 50% of the games. And I wanted to see if there was actually a correlation between um, how much a team spends on their payroll versus how they perform. And I noticed that there actually is not. There are some teams that spend way more, but they don't necessarily do as well. Um, And there's one year where, like, the New York Yankees, they spent so much more than the next team, which was Boston Red Sox, and they won the same amount of games. They did do better in terms of compared to other teams in the season. However, it doesn't make a huge difference. The interactive component is that you can use the dashboard. You can select the year to compare and look at each year and how much each team spent that year and how the average cost per win changes. I also looked at league parity, where it is the competitiveness. So I still wanted to look at the cost. The minimum salary you can see is um, on a rising slope, and the league inequality is the purple line. Basically, if it's above the dotted orange line, it means that there was clear, strong teams that year, and they were going into a game, they were the clear favorites. But then other years that are below the line, it shows that, hey, we don't actually know who's going to win. And I just wanted to look at, okay, if the salary is being raised, does that force the teams that aren't spending as much to perform better to keep up? Otherwise, there's going to be a huge discrepancy. And my findings were that there actually is not any correlation. My last graph is about draft performance. So the bigger circles are actually when they pick higher up on the draft, which means that they performed poorly the previous year. And then this is the black dotted line is the league average win percentage. And I wanted to see if they had a higher draft pick that year. Did they end up doing better that year and the following years? Or was it that they didn't utilize their top draft picks and it didn't really make a difference? So in some teams, it didn't look like it made a lot of difference. So you can see, like, for the Angels, they picked first in 1995, and then in 1997 they picked third, and then in 1998 they did better the previous year after they picked first and third, and then they picked 18th. But then you can see that their win percentage actually went down, um, as they were picking later and later. And then it goes up, but they didn't pick any difference. And one of the ways that I made this interactive is that the user can actually select different teams to compare to see. So we can see that the Angels picked 23rd, and this is average. And then the Dodgers, they picked 19th. They Angels did well that year, but then the Dodgers did not do well. So they actually picked uh, higher the next year or earlier the next year. And honestly, I think that if what I found is it affects it a little bit if the team utilized who they picked, but then it also feels like not all the teams really um, took advantage of that first draft pick. So I don't think there's really any correlation. I think it was very dependent on the teams. But yeah, so that's my dashboard project. Okay, so this is my code that I use to actually create that dashboard. My first part that I did was the scraper program. I had a little bit of hiccups when I was writing this program. It turns out I was actually doing it right. I just had second guessed myself and didn't realize that I didn't clean certain data. And anyways, so I ended up changing how I approached it. Originally I was scraping every single element, but the way I ended up doing this, and it sped up my program a lot, was I actually went to the website and I found all of the links for each of the years and I scraped the entire HTML for that particular page. And then from there, I found the table names. I found the tables, and I found the table names, and I found the columns, and then I found the table data. And this was actually a lot easier to organize and test. And just in general, it felt like I was able to keep track of things a lot more easily. Um, it also, I think, will allow this to scale a little bit better because if the baseball almanac changes one of these days and changes like how they uh, post or display certain information, it'll still allow my program to be um, adjusted, I think, in an easier manner than having to figure out how to access that program on their particular site instead of the HTML. And then from there, I actually wrote everything to a CSV file here. And you can see like over here, this is where I thought I was doing something wrong at first, but it was just because there were a couple of um, things empty empty stats. And once I was able to clean it up, you can see that there's actually no blank, but I saved it to a CSV file from the scraper. And then I actually used that CSV file to import to my SQL database. And here is where I kind of cleaned up the data. I made sure that there were any duplicate columns. I condensed down. I also standardized the columns. So I made sure that the items in the column were all the same type, so int or float, depending on um, what the column was. So like year, I wanted it to be a int every single time. For payroll, for any of the stats, I wanted it to be a float because it could be percentage, it could be a whole number. And then from there, I actually wrote a SQL query where the user can filter using the command line, the PowerShell, to um, look at specific teams or specific years. I also will join and aggregate certain columns or tables. And then my app, which, oh, sorry. And then I also did a main where you run all of this, all of the programs that I talked about first to collect the data. And then the app is what's on render. And I wrote all of the graphs here. Again, it took a little bit. There's still some things that I would like to improve, but overall, I'm really proud of how I accomplished and what I accomplished with this. And I definitely, something I learned is I love the cleaning of data. I like making sure that everything is valid and correct. I like making the graphs, but analyzing them and explaining, performing, not so much. Like I know what the graphs say, but explaining it is not my strong suit. But definitely I really, really enjoyed this program and I think I learned a lot. So yeah. Okay. Thanks for watching. Bye.